MagneMotion specializes in linear synchronous motor and maglev technology for the transport of people and goods. Applications range from material handling and assembly automation to elevators and people movers. Whether you need to carry 10 pounds or 25 tons, MagneMotion can develop an LSM that is right for your particular needs. LSMs generate propulsive force by running current through a stator, which creates an electromagnetic field. This electromagnetic field interacts with a set of permanent magnets on a vehicle to create thrust. The vehicle rides the electromagnetic field much like a surfer rides a wave. The vehicle's movement is controlled by a sophisticated control system. This is a demonstration of MagneMotion's linear motor control system implemented in our commercial QuickStick LSM. Each QuickStick shown here contains two half-meter-long motors. A motor may interact with only one vehicle at a time and must receive permission from an adjacent motor in order to send the vehicle to its programmed position. The adjacent motor either grants or denies permission based on whether or not it is occupied by another vehicle. Responsibility for the vehicle and for acquiring permissions is passed along from motor to motor as the vehicle moves down the line. If a failure occurs, no new permissions are granted, and all the vehicles come to a controlled stop, resulting in a reliable, safe, high-performance control system. This demonstration system shows the QuickStick in a variety of transport configurations. The horizontal position serves as an alternative to traditional conveyor systems operating on a single level. High-angle conveyor solutions are also possible and might be used to transport raw material out of an open-pit mine. Linear motors can also be configured as a vertical transport system, replacing cables, hydraulics, and counterweights that are often used in conventional systems. The QuickStick LSM easily integrates with existing systems, taking advantage of its modular design. Here the QuickSticks are integrated with a conventional assembly automation conveyor. The QuickSticks are placed only where an operation takes place, taking advantage of QuickStick's quick acceleration, bidirectional travel, and indexing capabilities. As shown here, independently controlled vehicles mounted to a common platform can create a second axis of movement, useful in assembly automation and other applications. The lateral movement can eliminate an axis on robots or allow easier access to payloads from the wayside. The same technology used to create a second axis of movement allows a two-bogie vehicle to navigate corners. As shown here, the rear bogie pushes the front bogie around the corner until the front bogie is positioned over the next motor. Once the front bogie is in place, it pulls the rear bogie through the corner. A turntable combined with a half-meter QuickStick LSM can be used as a cornering solution or as a switch to handle multiple pathways. MagneMotion's node controller provides an integrated solution with third-party actuators. Demonstrated here is the successful control and handoff of vehicles between the QuickStick LSM and the turntable. The third pallet to the right of the turntable demonstrates different move profiles on the same guideway system. Creating more or less force can be achieved by varying the magnet array configuration and length, the magnetic gap, the motor's duty cycle, and/or the system's requirements for acceleration and velocity. The same motors that carry a 20-pound payload at high speeds have been successfully deployed to propel an 8,000-pound payload at low speeds. This QuickStick demonstration shows a 350-pound vehicle traveling with a very large magnetic gap. This shows that QuickSticks can be mounted outside of an enclosure and move vehicles located inside of the enclosure. For cleanroom applications, this maintains a particle-free environment. And for a hazardous waste material application, this keeps the contaminated material isolated from human contact. MagneMotion's advanced technology products can be integrated into the design of new systems or used to augment and improve existing systems. Here we see a sophisticated linear synchronous motor system developed by MagneMotion that also features electromagnetic guidance and switching. A central control system guides the vehicle through load, unload areas, and numerous merge-diverge points, and serves as the primary communications link with other material handling equipment. MagneMotion's Urban Maglev system is based on a combination of linear synchronous motor and electromagnetic suspension, or EMS technology. This suspension system uses the attractive force between permanent magnets on board the vehicle to steel on the guideway to suspend and guide the vehicle along the track. Coils placed around the magnets on the vehicle allow the suspension system to be stabilized and to maintain the nominal operating gap of approximately 20 millimeters. The suspension, guidance, and thrust forces on the vehicle are all produced by the same magnetic structure. We can see the 3,000-pound demonstration vehicle lifting off first from the parked down position where the vehicle is at rest against the guideway surface. Power is applied to the levitation coils, which increases the magnetic attractive force of the vehicle to the guideway, lifting the vehicle to its nominal operating gap. We next see the vehicle lifting off from the parked up position where the magnets are touching the steel surface on the guideway. In this case, power is applied to decrease the magnetic attractive force of the vehicle to the guideway, allowing gravity to pull the vehicle away from the guideway. The control system immediately adjusts the vehicle to its nominal operating gap. Next, we see the propulsion system moving the vehicle along the guideway. The vehicle accelerates at a rate of 2 meters per second squared to a peak speed of 2 meters per second, which is limited by the guideway length in the indoor track system. The vehicle decelerates to stop at the intended indexing point, again at a deceleration rate of 2 meters per second squared. The vehicle indexes to the intended station location with an accuracy of better than 10 millimeters. This is MagnaMotion's Advanced Weapons Elevator Proof of Concept developed for the United States Navy. The LSM-based elevator successfully demonstrated a 12,000-pound lift capacity and represents one of 4 motors that will be used to lift a worst-case load of 48,000 pounds. Designed to move at 150 feet per minute, it accelerates to full speed in 1 second. Other features include motor thermal protection, emergency braking, and our smart control system that estimates payload weight. The design can be extended vertically without the limits imposed on cabled elevators. Perhaps most importantly, with the addition of switches, many vehicles can operate within the same elevator shaft, reducing floor space and increasing capacity. This fully programmable and scalable elevator motor and control system can be tailored to any application. MagnaMotion's scalable linear synchronous motor technology can offer you high speed and high throughput, few mechanical dependencies, precise position sensing, continuous propulsion, and fault-tolerant control. MagnaMotion, a force in electromagnetic systems.